Hello and welcome to Maths Polo YouTube channel. Today we are going to solve UPSC CSE Maths Optional Paper 1 2020 solution to question 5b. So the question statement says find the orthogonal trajectories of the family of circles passing through the points 0, 2 and 0, minus 2. So here we have the solution, that is, as we know, that x square plus y square plus 2gx plus 2fy plus d equals 0 is the equation to the family of circles. Now, given that it passes through 0 to 0, minus 2 and 0, minus 2. Sorry, here it is 0, 2 and 0, minus 2. Therefore, we have to satisfy these points with the above equation, or it is 0 plus 4 plus 2z into 0 plus 2f into 2 that plus d that equals 0. Now it is 4 plus 0 plus 4f plus d that equals 0. So we have further 4f plus d equals minus 4. This is first equation, and it is 0 plus 4 plus 0 plus 2 f into minus 2 plus d that is equal to 0. So it is 4 minus 4f plus d equals 0. So it is minus 4f plus d that is equal to minus 4. This is the second equation. Now we have to add first and second equation. That gives us 2d equals minus 8, or d equal minus 4, and we have f equals 0. Therefore, the equation of family of circles becomes x square plus y square plus 2gx plus 2fy plus d equals 0. So this become x square plus y square plus 2gx minus 4, as f is 0, so d is minus 4, therefore it is equal to 0. This is the third equation. Now carrying forward, we have to differentiate equation 3 with respect to t. So this become twice of x plus, sorry, with respect to x, because here we are differentiating this third equation with respect to x. So it is 2y dy upon dx plus 2g equals 0, or we have dy upon dx that equals minus 2g plus 2x upon 2y, or we can write it as 2z equal 2x plus 2y y dash, or g equal minus x plus y y dash. So further in the lecture, we have now put the value of g in the third equation. As we have obtained g here, so it will be x square plus y square, because this is the third equation. X square plus y square plus 2gx minus 4 equals 0. So it is plus 2 into g, which is minus x minus y y dash minus 4, that equals 0. And we have the differential equation, that is x square plus y square minus 2x square minus 2xy y dash minus 4, that equals 0. So this is the differential equation, and we have now, this is the most important point, that is now for orthogonal trajectories we have the condition, that is replace dy upon dx with minus dx upon dy. This is the most important point of this problem, because here we have to replace dy upon dx to minus dx upon dy. Now the equation becomes x square plus y square minus 2x square minus 2xy into minus dx upon dy minus 4, that equals 0. Now further we have the equation as x square plus y square minus 2x square plus 2xy dx upon dy minus 4, that equals 0. Or we have this equals x square plus y square minus 2x square minus 4, that is equal to minus 2xy dx upon dy. And further it is dx upon dy, that equals x square plus y square minus 2x square minus 4 upon minus 2xy. Now we have to solve this differential equation. So solution to differential equation is shown by green pen. So it is minus 2xy dx, that equals y square minus x square minus 4 dy. And we can write it as 2xy dx, that is equal to x square minus y square plus 4 dy, or it is 2xy dx, that is, sorry, here it is minus, because we are taking it on the left hand side. So this become minus x square plus y square minus 4 dy, which is equal to 0. Or it is 2xy dx plus y square minus x square minus 4 dy, which is equal to 0. Now carrying forward, we have this as m dx plus n dy equals 0. Now this is of this m dx plus n dy form. Now here we have to look to the solution to the problem very carefully. Dou m upon dou y is equal to twice of x, and dou n upon dou x become minus twice of x. Further, given equation is not exact, as this is of the form m dx plus n dy equals 0. So now we have dou n upon dou x minus dou m upon dou y upon m, that equals minus 2x upon 2xy, which is equal to minus 4x upon 2xy, and this is equal to minus 2 upon y. This is a function of y. This cancels this part and this cancels this part, so it is minus 2 upon y. So we obtained minus 2 upon y, and which is a function of y. Therefore, the integrating factor is equal to e to the power minus 2 upon y dy, which is equal to e to the power minus 2 ln y, and this is equal to e to the power ln y to the power minus 2, which is equal to 1 upon y square. Now further, this is the integrating factor. Now we have the equation as 2xy dx upon y square plus y square minus x square minus 4 upon y square dy becomes 0. So it is 2xy upon y square dx plus 1 minus x square upon y square minus 4 upon y square dy, which is equal to 0. Now this is the final equation. So the solution to the problem of this type of differential equation is given as integration keeping y constant m dx plus integration terms of n not containing x dy equals c. So this is the way we have to solve such type of differential equation. So this can be written as integration 2xy upon y square dx plus integration 1 minus this is 4. So here we have only two terms, which is 1 minus 4 upon y square dy, which is equal to 0. So this become 2y upon y square into x square upon 2 plus y minus 4 y to the power minus 1 upon minus 1 equals c. Now we have x square upon y plus y plus 4 upon y, which is equal to c. So further we have x square upon y plus y plus 4 upon y equals c, which is the required equation, or you can say the answer to the differential equation or the solution to the differential equation. So we have finally this as the solution to the above differential equation. I hope you liked the video. So please stay tuned with Maths Polar YouTube channel for more such solution to the UPSC CSE Maths optional paper 1 and paper 2. So please hit the like button, share and subscribe to the channel for more such latest solution videos. Thank you.